So that's the taxi cab distance. Then there is this thing called the Spidey distance. So there's the taxi cab distance, and there's the Spidey distance. Spidey distance allows diagonal paths within these grids. And that diagonal path has length 1.5. So if I want to go from here to here, I could do that diagonal, I could do that diagonal, and I could do that. So I would have a total distance of 1.5, 1.5, 3, plus 1, 4. So in a taxi cab, it'll take me 5. In the Spidey distance, it'll be 4. Is that clear? Okay, so those are your two distances, and they are defined on this grid. Now you're asked the question, you're given a taxi cab distance, and I forget the notation it used. What was the distance notation it used?
I'm a little confused on that one. So I'm so
No,
sorry.
notation. What letter did it use?
For that one,
T and S, thank you. Yeah, so taxi cab was T, and Spidey distance was S. So you're given limits on T and S. So for instance, that one example that it has there, it says try T equals 4 and S equals 4. So somebody tells you T is 4 and S is 4, which means you're looking at points that are within taxi cab distance of 4, and then you're asked how many will have Spidey distance of less than 4.
You can go back to the problem.
Yeah,
I
I think
here.
I need to know. Okay. Right, so now we want to output a fraction, n divided by d, which is the fraction of points within the given Spidey distance that can also be reached within the given taxi cab distance. Okay? Thank you.
Okay, I think should be good.
Okay. So one way to do this is by brute force, where you say, let me count all the things within a Spidey distance of S.
I couldn't understand.
Sorry?
I couldn't understand like what's the output there is.
No, I'm telling you,
Okay.
listen first. You're counting how many points are reachable within a Spidey distance of S. Okay? So let's say these are all the points that can be reached within a Spidey distance of S. And within this range, you want to count how many have a taxi cab distance of T. It's possible that only this here, it has a taxi cab distance of T. Let me use a different color. So only a fraction of it may be within a taxi cab distance of T. You want to know how many are these. You want to know that ratio. You want to know how many points are here divided by how many points are in this big region. Is that clear? Because you're thinking about the method. Forget about the method. Are you understanding the concept? I want to know all the points that are within Spidey distance of S. What's wrong with that? That's clear, right? So I count all the points that are within Spidey distance of S. Among those, I want to know how many have a taxi cab distance of T. That's all. And I want that number, that ratio. Okay? Now how we do it is part of the algorithm that we have to design. Fine? So we're first figuring out all the things that are within a Spidey distance of 4. Actually, is it the other way around? I'll put a fraction, which is the fraction of points within the given Spidey distance that can also be reached within the given taxi cab distance. And I think the first problem is 4 and 4, right?
Yeah.
All right, all of them. Oh, no, because taxi cab is a little longer. Okay.
Spidey's a little longer. Because with
Spidey-
Spidey, you can go diagonally with
Right, but
cost
it's,
of 1.5.
but it's, this is at distance 2 along a taxi cab and Spidey is only 1.5, so Spidey is less.
Oh, yeah, Spidey costs less, you can reach out further with Spidey. That's what I mean.
Ah, okay, right. Okay. You can reach further, right. You can reach further taxi cab distance. Okay, good, yeah, that's right. So what are all the points that can be reached within a, so let's try this. Which points are reachable, at least in this quadrant, which points are reachable within a Spidey distance of 4? So this guy here is at distance 4, right? So is this, because I can get here and then do that. Then I could do 1.5 plus 2, 3.5, so this also works. This also works, this also works, this also works, this also works, this works, this works, this works. What else? I can reach here as well, right? Because that's Spidey distance of 3, right? And I can also go to this because it's 4. Can I go there? I cannot. Well, I can do 3 plus 1.5, that would be 4.5 distance.
Yeah, the one below.
The one below this one?
Yeah.
1 and 3, or actually it's just even less, yeah, of course. Yeah. So these are all the points in this quadrant, right? And so you can see how many there are. That's 3 plus 3, 6, and 2, 8. So you'll get 8 times 4, that's 32. And then you get 33, and then you can add 16. So 33 plus 16 gives you 49. Okay? So if you just go and brute force count it, the number is 49. I'll do the same thing on this side, I'll do the same thing on this side, and I'll do the same thing on this side. Is that clear? So, so the number of points that are reachable within Spidey distance of 4 turns out to be 49. You're still staring. Is it clear? Not clear.
I think that you are duplicating some points.
Duplicating some points.
Because you're counting down to the
This
edge.
here is how many?
Ah, okay, yeah, the 3, 6.
That here is
7, 8, say 8 points.
8. So 8 times 4 is?
Oh, there we go. Yeah,
32.
You're right.
32 plus 1 is 33, and then I get 16 from the 4 legs.
Right.
So that's 49. Clear? Okay. So now we want to see how many of these points are reachable by distance, taxi cab distance 4. So let me use a third color. So taxi cab is green in color. Clearly I can do all of these, right? I can do all of these because that's 1 plus 3. Then, wait a minute, here I forgot to add this one here. What happened? 3, 3, 6, so no, I did get it right, okay. Then I can reach this. Can I reach that?
No.
Obviously I cannot. So I am too short in each of the quadrants. So I'm going to get 41 divided by 49. That's the answer that is expected here. Is that clear? So I'm missing 2 in this quadrant, and I do the same in each one. All right. Now this was okay as long as numbers are like 4 and 4. But they're telling you that the numbers T and S can be as big as 1,000,000. So you're not counting anything for sure, right? So the question is, how do we do this?
One thing is the taxi cab, it has a really nice structure.
Taxi cab is a lot easier than the Spidey.
Yeah.
So before you tell them that, let me make sure that they're in the same place. which kinds of points are reachable in some given distance by the taxi cab. All right, so,
Right angle triangle.
sorry,
Right angle triangle.
right,
Right angle triangle.
right angle triangle. Yeah, you're right, that's exactly right. So it turns out that in distance 0, you're gonna stay there. In distance 1, you're gonna get to these 4 points. In distance 2, you're going to get to that one, that one, that one, that one, that one. Right? So you see that in distance 1 it was this, in distance 2 it's this. So what do you see? Distance 3 is going to be like that. Is this clear? So the pattern is somewhat clear. You can count this for whatever number you want, as long as you write down this functional relationship. Are you with me? So an easier way to think about this is to say, first of all, each of these is diamond shaped, right? You can figure out how many points sit on the diamond, because those are the number of points that get added every time, right? So the first time around, I just add 1. Second time around, I add 4. The third time around, how many do I add? 8. How many will I add here? So I'll add 1, 2, and 3. Sorry, will I add 3? No, I will add 2, or is it 3?
2.
So I'll get 1 point here and 1 point here. So I'll add 2 there. So it'll be 2 to 4, 6, 8, and then 4 along the edges. So that's 12. Is that clear? So the numbers were what? In the first diamond it was, well, let's say at level 0 it was 1, at level 1 it was the first level diamond, so it was 4. Level 2 was the second level diamond, that was 4 plus 4, 8. Third level diamond was 12. Fourth level diamond, it'll have 3 points along that thing, and you'll have 3 plus 3 plus 3 plus 3, that's 12, plus 4 will be 16. So you can see that every time it's adding 4 points as it goes out, right? So you can pretty much figure this out. If you ignore this one, every level it's 4 times this level I, and that's what you get here, and you have to add 1 to it. This is 8 times I, this is 12 times I, what did I do? Essentially, if I want to go to the ith level, it's going to be 4 times I here, and I have to add all these numbers in order to get how many points I'm able to reach, right? So I am adding 1, which is special, plus I'm adding 4 plus 8 plus 12 plus 16 plus whatever, all the way up to 4 times I. Right? Or I can say 4 times, what is I, by the way? These are things that are reachable in distance 1. These are things that are reachable in distance 2. These are things that are reachable in exactly distance 3, exactly distance 4, and so on. So I is exactly the distance of the outermost points. So if I want taxi cab distance of t, I'm going to just replace the I with a t. Is this clear? So what I get here is 1 plus, I pull out 4 in common, I get 1 plus 2 plus 3 plus 4 all the way up to t. And what is the sum of the series? This is just a regular summation, so that's t times t plus 1. So you will get as the answer here 1 plus 4 times t plus 1 divided by 2. This 2 and 4 will cancel out, so you'll get 1 plus 2t times t plus 1. Whatever that number is, that's your answer. So this will give you 2t squared plus 2t plus 1. That's your formula. That's the number of points that can be reached with taxi cab distance of t. Are you with me so far? So you can plug this in for t equals 4. You get 4 squared is 16, 16 times 2 is 32, 32 plus 8 is 40, 40 plus 1 is 41. Good? Now you can be sure that the Spidey distance is less than or equal to the taxi cab distance. So everything that this taxi cab can reach in distance 4, the Spidey distance can also reach. Right? The only thing is we want to know how many extra points it's able to reach. So that means all we have to figure out is outside of this diamond, that diamond shape that we have, we want to know how many points. So you can draw a diamond shape by doing this diamond over here. All we are asking is how many points outside this region have the Spidey distance that you want to say, that you want to program. Is that clear? So now we have to figure out how many points have Spidey distance of 4, or 4 or less. So question is, how do we do this? Isn't it t minus 2?
Yeah.
What is t minus 2?
So
The Spidey distance?
like the number of points outside the
Well, that was true for s equals 4 and t equals 4. If I change those numbers, it may not be. If I gave you t equals 4 and s equals 5, or t equals 4 and s equals 3, your answer may be very different. Right? So what we need to know is how to compute the number of points that we can reach with Spidey distance s, but we do have to differentiate between the case when s is at least t or when s is less than t. If s is less than t, you'll get a different ratio. You may see that not all the points that you can reach with the taxi cab distance can be reached with the given Spidey distance, right? If I say t equals 4 and s equals 3, now which ones can you reach here? Well, we'll have to kind of think about this, right? If you can reach, so that's 3 plus 1, 4, so I can definitely reach here, but can I reach here? And looks like it's not so, right? So I can reach this one, but not this one, or this one, or this one, or this one. So all these are not reachable if I make the Spidey distance to be 3. And of course, I can't reach this one either. So it seems I can only reach that one. So there are some, it starts to become more complicated now.
Just so the output is asking, you're given all these Spidey points, how many of those are reached by the taxi cab distance? Is this
I
the
know it's
same?
asking the other way.
Yeah.
And all we are doing so far is to say, yeah, the taxi cab is easier to figure out. Now we are trying to overlay this on this, what our Spidey distance boundary is. And what we've seen, even with simple examples, is that the boundary is not so clean, not so nice as this diamond shaped, right? So first thing for us to see is there some shape that we can describe? If we can, then we can manage it. Otherwise, we have to do something else. And the reason I broke this down into 2 possible cases was that if s is at least t, then it's a lot easier to compute what goes outside of that range. In fact, one way to say, is it enough just to count how many points can be reached with s equals 4. And because this is the denominator, is it the yeah, because this is the denominator, we can just count this anyways, right? And in order to count this, it seems that it might be easier to start with all the things that you can reach with a taxi cab distance of 4 and then go beyond it. So whatever this number is, if this number is 7, I would first count how many points you can reach with taxi cab distance 7 and then figure out how many fall outside that diamond shape. That's why I'm going at it the other way, but maybe you have a different approach to this.
I don't wanna, I was working on this in the morning.
Yeah.
I did end up getting it.
Uh-huh. You did end up getting it,
Mhm.
and you have a different approach.
Well, I started the same way thinking about it, but I couldn't find a nice shape to this Spidey distance thing.
Uh-huh.
There just wasn't any good structure to it.
Yeah, so here's the way that I've been thinking about it. The only thing difference with the Spidey distance is this diagonal things, right? And clearly you want to take as many diagonal things as possible because it really cuts down on your length. Because instead of going 1 plus 1, 2, by doing this diagonal, you're getting 1.5, so you're squeezing out a 0.5 of the distance. So if I want to go from here to whatever there, I would first go as much as possible diagonally and then simply take a straight line shot, either horizontal or vertical. This is going to be my strategy for figuring out what's reachable within a certain distance. So if you tell me the Spidey distance is 17, I'm going to figure out how many diagonals I can take in this, and that will start to give me the points that are reachable. That's what I was trying to say. And anything below it and to the left of it, we have to do some extra work, but I think I could work it out. At least that's what I'm going to try and approach this. Anyone else with other ideas?
No good ideas.
Yeah, okay. So, if I fail, we'll go back to your approach. Let's see where we can go with this. So let's say that I want to know how many points, how many things can be reached with some Spidey distance. And just for the heck of it, I'm going to take s equals 7. Okay. So what I'm saying is, I will first draw this grid. I will first look at the things that are taxi cab distance of 7. And let's say this is my taxi cab distance of 7. We know exactly how many points are here because we just calculated it. All I have to figure out is how many more I can reach outside of this on each one. And then all I have to do is multiply it by 4 and add this up, right? So I'll just focus on one quadrant and figure out how many extra points I can reach with that same Spidey distance as this taxi cab distance. So here I went with taxi cab distance of 7. So I'm going to go with the Spidey distance of 7 and see how many more I can reach. So for that, what I'm going to see is the following. I'm going to look at this diagonal here. So here, distance of 1, distance of 2, distance of 3, and so this is distance of 7, right? So if I do 7 such rows and columns, then I will get to this point. So this line here corresponds to x plus y equals 7. All the coordinates are going to satisfy this. Is that right? Yeah.
Wouldn't that exceed 7
Yeah, I did make a mistake here.
if the green line
Yeah,
is...
it's not seven layers. Yeah, I did make a mistake there. So, in fact, if it's 7, it's going to be 1, 2, 3, and then 4 on this side. Or it's going to be 3 on this side and 4 on this side. So it looks something like this. So I should take an even number just to make this easier. Looks like even and odd have different behaviors. So let's try s equals 8. Now, hopefully it's more clear what we have to do. Let me draw a bigger picture. Remember, we are only focusing on the top right quadrant. Get this, right? So, yeah. So this is at distance 2. Right? This guy here is at distance 2. If I go one more up and one more down, what is this distance?
4.
4, right? Then we have 6. Then we have 8. So this is now at the maximum taxi cab distance of 8. If I want, I can also find, so there's also a point here somewhere. There's also a point here somewhere. That's also, so all these points are along the straight line where x plus y equals 8. Right? So if I think of this as the x coordinate and this is the y coordinate, this here, the line here is x plus y equals 8. Right? So all these points will lie on exactly taxi cab distance of 8. Right? Now my question is, what is the Spidey distance here? And the Spidey distance is some multiple of 1.5. And so I can reach here in 1.5 times as many layers as they are. So it's 1.5 times the taxi cab distance divided by 2. Right? That's the Spidey distance to this point. Is that clear? Wow. So what is this going to be? This is, let me just say 3/4 of t, right? It's easier to write it this way. So I have only traversed 3/4 of the t distance, and so I have some more distance to go. I can go another quarter t distance, right? So I've gotten here already in 3/4 of 4 is going to be 3. So I've only used up 3 units of my Spidey distance. I have 1 more unit to go, right? If I have 1 more unit to go, where can I get? And clearly, I can go 1 unit this way or 1 unit this way. I cannot go 1 unit diagonally. So really, all it'll do is it'll include all the points from this next diagonal. Is that right? Yeah, that is right. It's not the next diagonal that way. You can't get to here, but you can get to this diagonal. And so this is going to be x plus y equals 9. Whatever number of points you have over there, that's going to be the set of points. Oh, no, wait a minute. You can reach these two, but now the question is, can you reach that point? And the answer is no, because this is going to be 4.5 plus 3 will give you 7.5, and that's still okay. Right.
So as you go up, you're gonna have your leftover points.
You'll add more points, but the question is how many do you want to add, right? I mean, that's what we have to figure
I'm
out.
saying, like, as you go up the line,
Yeah.
the amount of Spidey distance that you can use goes down. So you have to use regular distance to move up. So you're, the
That's
top
correct.
part,
Yeah, that's correct.
you're not gonna be able to reach the points at the top of the.
First of all, along, so you cannot get past this row or this column. You can only stay within here or within here. You can't get to that part of the quadrant. Because that's gonna require at least 2, and
Or you can go 1.5.
you can't go 1.5 because you've already used 3. Have you?
But S is 8 in this case, right?
Oh, S is 8, yeah, you're right.
So we have 6.
So therefore this is 6.
Yeah.
So I can go 2, I see. So in this case I can go 1 more, right?
So that guy and the guy above him
Yeah.
can both reach 3 points.
Right.
The other
So
one.
let's first do 7 and then we'll do 8. That way we'll know exactly what are new things that get added for every distance. So we've come to 6 so far, right? So with 7, all I can do is go 1 this way or 1 this way, right?
Mm.
Okay, I can't get there. Now the question is, can I get there? And
Yeah.
it seems that I cannot.
With S equals 7, so
I cannot get there because, well, that's
you have
3.
1.5.
So I'm doing 1.5, then 3, 4.5, and then 2 would be 6.5.
6.5, so you can get there.
And I can get there. Okay, so this is also okay. And so therefore this also is okay.
But since that's 6.5, you can't go.
It
up
means
or
I
down.
cannot go any higher.
Yeah.
And so then I can definitely get to these guys here. There are 2 more here, right?
And once you know that the,
Everything to the left of it is okay.
Yes.
Yeah.
well, everything up and left is wrong. It's not gonna be okay.
Well, no, this is okay. These 2 are okay. These 2 are okay. Right?
I mean, for the next one in the sequence?
For next in the sequence, I cannot go any further, but can I go here?
I think that means you can't.
You cannot. Are you sure? Because this is 3, and then I can go 4, 7, so I can go here.
Oh, okay.
I can go here, which means I can also do that. But then it is, can I get there is the question, and it looks like I cannot because that's 1.5 and I cannot go 6 more. So it starts to get kind of weird.
Well, this means that if we can very quickly calculate the taxi, so the spider distance to the farthest taxi one, it's pretty easy to get the rest of it.
It's not clear. How is it easy?
Because we know how much we have left, and and it's not gonna be that many calculations.
No, but if S is if T is 1,000,000, then you're gonna have a lot of trouble
So
trying to figure that out.
if T is 1,000,000 and we're at the edge, there's gonna be.
And is there a difference between even and odd? These are the questions that you kind of figure out. Right?
Okay. It looks like there is a difference, but.
It looks like it's doable, but I'm trying to nail it down to some clear cases that I can explain to you. Right, so I think the way to do this is to say, what is the Spidey distance of all the points along this border? And then we can figure this out. So this here is 4.
Oh.
Because we went 4, this is distance 4 away. Spidey distance is also 4. The Spidey distance to this guy here is not 5, but it's 4.5. Right? So this is 4.5, this is 5. Is that right? 3 and 2, 5. This is 5.5, and this is 6. So the Spidey distance goes down by a half along this. And that is going to help you to figure out what new things you can reach. Because now you're asking, what more can I reach in whatever is Spidey distance is left over, right?
But isn't that still messy?
Is it messy? I don't know. I'm also thinking for the first time with you, so. Because extra 0.5 really doesn't get you very much,
Well,
right?
The bigger S gets, the better the Spidey distance gets, right? Because you can reach farther.
Right, but here is the key, right? If I want to know what else I can reach along here, all I have to know is this is 5.5. I have to ask how many is remaining, and it's since it's a straight line, it's just the taxi cab distance. So if I'm looking at 8, I know I can only reach 2 more. And here I can reach 3 more, here I can reach 3 more, and here I can reach 4 more. So every other one will increase by 1. And so it's more a matter of sum of a series here. You guys don't look too happy with
Yeah,
me.
so you're saying how far can we go going diagonally? And
Right.
the rest of the way we have to move.
So remember, the Spidey distance goes in increments of 1.5 or 3, right? So I'll first do the diagonals, and then I'll do a straight line. So let me try and yeah, I think I'm seeing a way forward. All right, so here I am at the origin. I'm only interested in this quadrant. I don't care about the other quadrants because it's all a multiplication by 4. Great. So let's say that you tell me S, you give me a value of S, whatever that value of S is. What I'm going to do is to divide this by 3 so that I know along the diagonal what's the farthest I can go. That's my first job. Fine? So when S was 8, I could only go 4 steps because it'll be 1.53, 4.56. I can't go beyond that. Wait, I could go
Yeah.
7.5.
7.5.
I could go 7.5. Yeah. I could go 7.5. Actually, over there I was doing 7, and that's why I couldn't quite get that. Yeah, sure. So I figured how much what's the farthest I can reach along the diagonal. Okay? So given S, I do S divided by 1.5, and that tells me how many I can go. So I will go through all of this. All these guys are reachable in that distance. So now I have reached something where this is S divided by 1.5 and this is S divided by 1.5. Is that clear? Of course, it's a floor or ceiling, floor, right? Did I get this right? Yeah. Is that clear? So if S is 7 divided by 1.5, the best you can do is 4. Right? So I have reached so far S divided by 1.5 floor. That's what this is. This is S divided by 1.5 floor, comma, S divided by 1.5 floor. That's the X coordinate and the Y coordinate. And now, whatever extra I have is it all depends on how much of S I've consumed and whatever is left over. Is this clear? Right. No, so I don't want S divided by, what did I do here?
1.5 because it's diagonals only?
Sorry?
1.5 because it's diagonals only?
1.5 because it's diagonal and I've used up that much of the distance. But is this correct? Yeah, this is correct. Okay, fine. So I have now used up almost distance S. I have probably either 1 or two more left. Right? No, not 2. I have only at most 1 left, right? So if it is 7, I would have used up 6, so I have 1 left. If it is 8, I would have used up 7.5, so I would only have 0.5 left. So either I would have 0.5 left or 1 left of the Spidey distance that I could cover more. Is that clear? So this guy is at distance S from the source. So this is distance S. This is distance S minus 0.5. This is distance S minus 1, and so on and so forth. I'm going to use this to figure out how much more I can go along this or along this. I will not be able to go anywhere further within distance S for sure. Well, in fact, if I've already used up S, if this is a perfect integer, I won't be able to go any further along this. If it's not a perfect integer, I could go 1 more along this. That's the best I can do. So it's possible that along these two, this row or this column, I may get one extra in each. So it's possible that I can reach this and this if this is not a perfect integer. Right? When I divide by 1.5, if I get some remainder, then I can reach some more. Over here, now, I have to figure out how many more I can do. So I can add how many I can go here, how many I can go here, how many I can go here, and so on. And for that, all I have to do is to figure out if this is at distance S, this is S minus 0.5. If this is at distance a little bit less than S, then it's that minus 0.5, minus 1, and so on. And then all I have to do is to add up how many things I'm going to have left over there. So now I can figure this out. Let's see. So let's do S equals 7. If S equals 7, this point here is at Spidey distance 6, because I can only get to 4 of these columns. I can only get to 4, 4. Is that clear? The point 4, 4 is at this Spidey distance what? Is 1.5, 1.5, 1.5, and 1.5. So it's going to be 6. Is that clear? So this guy is at Spidey distance 6. So therefore, since I want S equals 7, I have one more unit of distance to go. So therefore, I can reach either this neighbor or this neighbor. Is that clear? I don't see any sign of people agreeing with me. You don't look too happy.
Yes, I'm trying to think. You said that the spider was number 6, right?
Sorry?
You said that spider was number 6 or number
This
7?
corner here has distance 6 because this is 1.5, 1.5, 1.5, and 1.5. I drew one extra here. That's why you don't like it. Okay, you're right. I should fix this. Okay, now, this is 4, 4, and it's at Spidey distance 6. Why? Because this is 1.5, 3, 4.5, and 6. Fine? Okay, let's say we want to know how many points can be reached with Spidey distance 7. Since we've already used up 6, we can go 1 more, so that gives you either this or this. Those are the things that are also going to be reachable in 7. Fine? Now the question is, what is the Spidey distance of this guy from the origin? What I'm saying is, if this guy is at Spidey distance 6, this one is at Spidey distance 5.5. Okay, that's what we figured out a little bit earlier. So if this is 5.5, and if I want to go all the way up to 7, how much more can I go? I can only go 1 more. So I get only 1 more along this column, and 1 more along this row. Right? Then I come here, and the Spidey distance here is now 5. Since I have 5, I can go 2 more. So along this column, I can go 2 more. Then here, Spidey distance is 4.5, and I can only go 2 more. Then finally over here, Spidey distance is 4, so I can go 3 more. So all I have to do is to add these up, and I would have the answer. Okay, so what I'm saying is, in order to figure this out, I will first figure out how much I can reach in this square, right? That's a fixed number of points. I can figure this out because here there were 3. What's the easiest way to count this? So I have 1, 2, 3, 4. 4 times 4 rows, so that's 16 points. Sorry, I shouldn't be counting this row here. So that's 4, 8, 12, 16. Yeah, I didn't count it right. So there are 16 points here in this quadrant that are not on the axis. Fine. And then 16, 16, 16, 16. That'll give me 64 plus the things along the axis, and that's 4 more. So that'll give me 80 plus the center one. That's 81. That's going to be my answer for all the things that I can reach within this part of the map. Now the question is, how much more can I reach? And I'm saying I can add up these, what I can reach along here. I can add up what I can reach along here. Anything here is not reachable. Okay? At least not in Spidey distance 7. So if this can go 1 more, the next one can also go 1 more. Then the next 2 can go 2 more. Then the next 2 can go 3 more. The next 2 can go 4 more. This is also another simple series. So it's going to be 1 plus 2 plus 3 plus 4 all the way up to some number, and we just have to figure that out. In this case, because we are doing 7, I'm going to get 1 plus 1 plus 2 plus 2 plus 3. And so this number is whatever that number is, so it's going to be 9, right? I did add the one along the spine. Maybe I shouldn't have done that. So let me remove this 3 here, because everything on the spine is somewhat easy to add up. So that means I only can add 6. So that means within this quadrant, there is 7 that's inside here. This number here is 7. This number here is 6. And then here also there's going to be a symmetric 6. So 7 plus 6 plus 6 will give me 21. No, 19, sorry. So I get 19 points from here, and then I'll multiply it by 4 and count the numbers on the spine. I'm done. So that's for distance 7. For distance 8 is another special case, and then for 9 again, it'll become like before, because it will be divisible by 3, right? So, right. So in order to do 8, what you'll see is that after doing 4 of these diagonal runs, I can only do 2 taxi cab points. So I'll get 1 extra point here. Then for will I get 1 extra point here or not? That's the question, and looks like I would. Is it? It's a distance 6. No, I'll get 1 more point here, 1 more point here. So remember, now we're doing s equals 8. I should use a different color. So let me put this guy here, this guy here, this guy here, right? Because this here has Spidey distance 6. I would get all 3 of those. This is 5.5, so the best I can do is 1 more here, and then I will get 1 more here, 1 more here, and then 1 more here. That's what will happen. Okay. So you will see that what will you see? This is the same as asking the question, how many can you reach in taxi cab distance 2 over here? And then for this part, you have to do this Spidey calculations where you're saying this is at distance 4.5, 5.5, this is at distance 5, this is at distance 4.5, this is at distance 4. How many can you go along those lines? And so those numbers are just, each one is going to get 1 added to it. So you're gonna get 2 plus 2 plus 3 plus 3 plus 1 plus 1, I think. No, you won't have that 1 plus 1, that's all you'll have. And so this number is 6 plus 4, 10. That's what you get over here. This will be another extra, this is taxi cab distance here. You're asking how many can you reach in 2? So that we know already is just 3 extra here. So you get that, the 3 extra over here. And then you'll get another a 4 extra over here because of the same calculation. So you'll get 7, no. You will get the original number that you reached over here, which is 7, right? So you get 7 plus 2 times 10, that's 20, plus 3. And so you should get 30 points in this region. How do we turn this into a algorithmic approach? So let me quickly recap what I did, and then we can see if there's a better way to solve this. So the first thing that I did, remember the problem I'm trying to solve right now is if I gave you a Spidey distance of S, I want to know how many points I can reach, right? So what I do is I divide S by 1.5 and look at the floor of this. That tells me how many diagonals I can take along the diagonal and how far I can go. Fine? So if I take S equals 7, I know that when I do 7 divided by 1.5, it's 4 plus some change, right? So therefore, if I do a floor, it'll give me 4. So that means I can go 4 units along the diagonal, and that'll get me to a distance of 6. And since I want to try S equals 7, I still have a little more distance to go. And so all I have to do is to figure out how much I can go further with distance 1. Now with distance 1, I can either reach this or this. I cannot reach anything else here. And then I can reach a bunch of things along these lines or along these lines. That's it. And that is easily figured out because all we do is take the diagonal and then figure out how much more straight we have to do. And we know the Spidey distance of each of these points. If this is 6, this is going to be 5.5, this is 5, this is 4.5, and so on and so forth. It goes down by 0.5 every time. And so that tells us how many more you can go along that line. And so then it's just a matter of counting this up. Now there's one other case, and that is because we are dividing by 1.5, the remainder, the slack could be either 1 or 2, or it could be an exact division by 1.5. We have to work out the case when it's an exact division by 1.5, but for now let's just focus on S equals 7. We just figured that out. So what happens if S is equal to 6? If S is equal to 6, you can reach here and nothing else. So that means this whole region is shut off. You can't go anywhere beyond this. All this is shut out, right? This is it. And then the question is, how much further can you go? And look, this is going to be 5.5, so you can't go any further. This is 5, so you can go one more. This is 4.5, so you can go one more. Then you can go 2 more, and so on. So every second you can go 1 extra unit along that direction. And so you are simply adding 0 plus 0 plus 1 plus 1 plus 2 plus 2 plus 3 plus 3, and you're adding as many as s divided by 1.5. So all that you can calculate. I'm not going to do it now, but at least it's a reasonable calculation. So if it's exactly divisible by 1.5, it's a simple one. Then you have to take care of 2 other cases, if the slack is 1 more or 2 more. If it becomes another s plus 3, then 6 will become 9. Again, it's divisible by 1.5, and then it'll get back to the usual number. Okay?
So let's say s equal to 6, right?
Yeah.
So like let's say on that y-axis,
Yeah.
we'll get 6 points.
No, we have only 4. So I'm only going 4 because I'm focusing on what I can do along the diagonal.
Yeah. No, I'm thinking through one.
Yeah, but you're thinking, I want you to bring you in line with what I am thinking, then you can tell me
Yeah,
what you're
okay,
thinking.
okay.
I'm saying, how far can I go along the diagonal first? And I can only go 4 because each one is 1.5. Once I get there, I want to know how much more I can go along here. And that I can measure because here I cannot go anymore because I've already used up 6. Here I've used up 5.5, so I can't go anymore. Here I've used up only 5, so I can go 1 more, then 1 more, then 2 more, and so on. So from 4, I will get 2 more. So I get to your 6, it's just that I'm adding it up later instead of adding it first. Maybe there's a simpler way to do this summation, but this is how I've been thinking. And at least the summations are relatively easy for me to figure out. Okay? So 6, or if a multiple of 1.5 is easy. If you want 7, then you have to do a little bit extra work, and if it's 8, you have to do some more extra work. And each of those involves taxi cab distances, not any diagonal distances, because you've used up all your diagonal distances. Okay? So you use this up, and then you do the ratio that you have to output. You have to be a little bit careful because they ask which ones can, of the ones that have Spidey distance S, how many can do taxi cab distance T? So it's possible that there are some that can be done in taxi cab and some that can be done in the Spidey distance. If one is not completely contained in the other, it's a little bit extra work. You have to kind of figure that out. Okay. Now, your method.
Very similar approach.
Yeah.
But I started thinking about what is the cost for any given point, and
Cost. Okay.
so, like you said before,
Meaning distance from the source.
cost doesn't mean like T is your cost. So if you go up 4, your cost is 4 for taxi.
Yeah.
Same thing for Spidey.
Yeah.
So my first thinking was that diagonals are always optimal. So we want to take as many diagonals as we want.
Right.
So if we want to reach some point X and Y,
You do first as many diagonals as possible, then you do as many straight lines as possible.
I do, yeah, I wrote it in like a math way. I defined some variable, which is the minimum of X and Y.
Yeah.
This is how many diagonals I'm gonna take.
Okay.
And I know that if I want to get to X and Y, the cost is gonna be X minus this variable,
Yeah.
which is minimum of X and Y,
Yeah.
plus Y minus this cost again, it's minimum,
Okay.
plus 1.5 times this minimum
Which
value.
is roughly this
Yeah.
number here. Yeah.
So it comes down to X plus Y minus 0.5 times the minimum of X and Y.
Yeah.
And we want this to be less than or equal to the Spidey distance.
Yeah.
So I just iterate, I fix some X value because it's only 1 million.
Yeah,
I find the highest point, using this formula.
yeah,
Initially, the highest point is always just S
right.
for the very
because it's
first,
along this. Yeah.
first column.
Uh-huh.
And then when I move
Then
to the
it
right,
goes-
it keeps going down
Going
until some
down.
point.
Yeah,
And
well, it'll go down in pairs.
I don't even care about this.
Yeah.
I kind of like that idea we're doing the binary counting where it always goes down until some point, and I always keep track of this.
But then you'll be spending time that's proportional to n,
Um,
n is 1 million.
Yeah, but n is 1 million is fine. So 10 to the 6 is okay, as long as it's not 10 to the 9.
Okay, so then it becomes a brute force.
Yeah. Because the counting is, even when you were saying this, it's still a little messy sometimes with those cases where one of them overlaps the other.
Yeah,
So if we just fix some X, find the highest point for Spidey.
well, so, if I change the 10 to the 6 to 10 to the 9, you'll be in trouble.
Yeah.
And then you have to resort to what I'm saying.
But even with what you're saying is, I don't know, it still seems,
It's completely deterministic. It's completely formulaic. It's just that I haven't written down the formula because I haven't thought it through.
yeah, I'm
But you can
saying,
see that,
I don't see the formula.
so I'll tell you the rough formula.
Mhm.
Can I say something? Basically, like, can I show you if you don't mind?
We're in the midst of a discussion. If you're going to take us in a new direction, I would say hold off. If you have something to contribute to this discussion, then please jump in.
It's a different idea.
It's a different idea. So why don't we wait? We can also listen to that idea. I know it's already time, so let me try and say what I'm trying to say. Whatever value of S you give me, it doesn't matter whether it's 1 million or a billion,
Mhm.
I'll just divide it by 1.5. That'll give me this point.
Mhm.
Then after that, I have 2 1s, 2 2s, 2 3s, 2 4s,
Mhm.
and I know how many I have to count because I know this number.
Okay.
Okay?
Mhm. I agree.
So I can write down a formula for it.
Mhm.
And so I can add that up with relative ease.
Okay.
If S is a multiple of 1.5, this is easy for me to do.
Mhm.
If S is not a multiple of 1.5, I have to add a little bit extra, which is really not that terrible a thing to do, and I can add that up separately. That's my point, and everything is a formula now.
Maybe I'm wrong in saying this, but
Yeah.
I agree that you can convert the Spidey distance into a formula,
Mm.
but at the end they're asking you, because it's only a proportion of the points that are Spidey points that are reachable by taxi cab distance.
Yeah.
That changes, it's no longer just find this, the amount of points
Uh-huh.
for Spidey distance, and that's the denominator, and numerator is taxi cab.
Well, but this is where I would use the other fact
Mhm.
that taxi cab distances are simply given by x plus y equals t.
Okay.
And so I know exactly which points I have to rule out. And once I rule out, it's going to be consistent across all the things I'm adding. It will chop off a diagonal,
Mhm.
and so the diagonal might be say somewhere here,
Mhm.
and I'll know exactly which ones get cut off. So all I have to do is to subtract out something where I'll be subtracting a consistent amount, because this also is a diagonal, except that the diagonal is flatter, right? So if you think about it,
It's like a staircase.
it is a staircase, but if you average it out, it's going at roughly half so for T, it's a precise diagonal like that, right? It goes at 45-degree angle, whereas this one goes something like this, right? It goes like that, and then it goes up by 1, like that, and it goes up by 1. So roughly, it's gonna stay below this, and you know exactly how much it'll go off. Well, most likely what will happen is that you have to see, your line may be somewhere here, and you have to see how many will get cut off. And once it gets cut off, it's gonna stay underneath. Once it doesn't, So this side, it'll be something like that, right? And you'll see that all these will stay. But you have to remove some part here, and that part is exactly defined by x plus y equals t.
Okay.
So I think that also is formulaic, at least that's my claim, because you know this area and you know this area, and all you're doing is subtracting. So my claim remains that it is formulaic, it's just not so pleasant.
Okay.
And it can be worked out. All right, let's hear you out.
So basically, like you have to, like for example, if I give s equal to 12, so you have to first step you have to minus 2. Like it's a brute force I calculated, but that's how. After that you have to minus 3 until it comes to like 2 or 1, and that will be the value of s.
Why do you have to subtract by 2 first?
Because like for example it's 12, right? So it will go beyond like 1, like 10. Like how you calculated that diagonal, right?
Yeah.
So if you go in that approach, you can reach out to 10 points with this. So after that, it will be 7, it will be 4, it will be 3 and 1. So like whatever number you take, if you take s equal to 37.
Yeah. So the only thing I don't understand is your subtract of 2, because 12 is divisible by 1.5. So I know for me that's a nice value of s. So I'm not quite clear about what you're doing. But other than that, so by the way, another way to think about this is that the Spidey distance is, so first of all, the taxi cab distance is clean, it forms this diagonal, right? So it forms this nice diagonal. The Spidey distance is, if you start with the same point, then it'll go at roughly half the slope on this side and on this side. And so whatever number of points you get here, it's going to be same as the number of points here. And if you can estimate this is going to be roughly half of that, because it's going to go at half the slope. And so there may be an easier formula for computing it, but this is roughly the idea. If this is distance t, then this is going to be Spidey distance of t divided by 1.5. There's some little extra fudge if the things don't divide properly. That's what I'm trying to say. But I think that this kind of broad analysis could be roughly right. We have to take care of some edge cases. Yours has worked because it's 1 million, but it could easily be changed to 1 billion, and you can try what happens then.
I'll see if I can come up with a close one solution. So
Yeah. You're not very hopeful, that's what you're saying. Or it's too much.
I see the structure, but
Yeah.
I just think it's too much work, yeah.
You think it's too much? I see. Yeah. Well, the good thing is that then I don't even care if it's 1 billion, right? It could even be higher.
Yeah,
Could
it
even
could be anything.
Yeah, it could be 10 to the 20 for all you care.
Mhm.
I'm going to have to stop here. I have a plane to catch. So.